Hello there. We're going to work on solving quadratic equations by factoring. Yes. Here's the formula for a quadratic equation. ax squared plus bx plus c equals 0, where a, b, and c are the coefficients. They're the numbers in the equation. Okay, notice this is set equal to 0. This is not. We're going to have to set this equal to 0. It's called the zero principle. So I'm going to subtract 16 from both sides of the equation, which gives me c squared plus 6c minus 16 equals 0. Now, remember how we factor a quadratic trinomial when a is 1. We look at the factors of negative 16. And what are they? They are positive 8 and negative 2. There we are, over here. Negative 16 equals negative 2 times positive 8. Negative 2 plus positive 8 equals the middle number 6. That's how we know which numbers to use. I factor c squared plus 6c minus 16 equals 0 into c minus 2 times c plus 8 equals 0. Then I set each of these linear binomial factors equal to 0 and solve for the variable. My answers, my solutions, are c equals 2 and c equals negative 8. And that's what I write in the answer box in my math lab. Here's another quadratic trinomial that's already set equal to 0. I factor 4 into 2 times 2. That gives me w plus 2 times w plus 2. I set each factor equal to 0, and unsurprisingly, when I solve each factor for the variable, I get the same answer on both sides. So negative 2 is the answer, also called the solution. Here we have v squared plus 5v equals 0. Notice we don't have a constant term, so we factor by GCF. Because each of these terms, contains a v. I pull v out to the front. We have v times v plus 5 equals 0. Set each factor equal to 0. The v is a factor, and v plus 5 is a factor. V equals 0 is already solved. V plus 5 equals 0 solves to v equals negative 5. So I have two solutions to this equation. Don't forget your 0. It's so easy to forget that little 0. Negative 5 and 0 are the solutions to the equation. Now here I have my quadratic term and my constant term, but I don't have the middle linear term. However, 6 is in the first term, and 6 is also a factor of 54. 6 times s squared minus 9 times 6 equals 0. So I pull out 6 as a GCF. Notice there is no variable pulled out with the 6. That's very handy, because since this is an equation, I can divide both sides of the equation by 6, by a number, not by a variable, but by a number, by a constant. 6 divided by 6, 0 divided by 6, leaves me s squared minus 9 equals 0. S squared and 9 are both perfect squares. So we'll have s squared minus 3 squared, and that will factor into s plus 3 times s minus 3. Set both factors equal to 0 and solve for the variable. I get s equals negative 3 and s equals 3. So that negative 3 and 3 are my solutions. Oh, there's Bubba. Hello, Bubba. He's letting me know he's hungry, but I think he can wait. Now here we have 18v squared equals 2v. This is a quadratic equation. So I'm going to have to use the zero principle, subtract 2v from both sides of the equation so that I get 18v squared minus 2v equals 0. Each of these terms contains a 2 and a v. So 2v is my GCF. So I have 2v times 9v minus 1 equals 0. I set each factor equal to 0. 2v equals 0 and 9v minus 1 equals 0. I solve both of these equations for the variable, and I get v equals 0 and v equals 1/9. Those are my solutions to the equation. Now here I have 3s to the third minus 15s squared equals 42s. This is a cubic equation, and it's a higher order equation. So just like with quadratic equations, I have to use the zero principle. And I should have written zero principle right there. I think I'll write it right now. Zero principle. Okay, come down here and come down here. Now we have 3s to the third. 3s to the third minus 15s squared minus 42s equals 0. When I factor each term, I find that each of these terms contains a 3s. So that's my GCF. 3s times the leftovers, s squared minus 5s minus 14 equals 0. I set each factor equal to 0. So 3s equals 0 and s squared minus 5s minus 14 equals 0. This is easy to solve. I divide both sides by 3 and I get s equals 0. Over here, I'm going to have to factor this quadratic trinomial into s minus 7 times s plus 2. Set each factor equal to 0 and solve for the variable. Okay, and notice that we factored negative 14 over here because there's an invisible 1 leading coefficient. Negative 7 times 2 gives us negative 7 plus 2, which is negative 5, which is the middle number, the coefficient of the linear term. And that gives us our answers right here. I was going to say 2 answers, 2 solutions, but no, I was about to forget the 0. Our solutions are negative 2, 0, and 7. Now here's an interesting fact that you need to remember for college algebra. If I graph f of x equals x squared minus 2x minus 3, I get this graph. The x-intercepts are -1, 0, right there, -1 on the x-axis, and 3, 0, which is 3 on the x-axis. -1, 0, and 3, 0 are the x-intercepts. But it just so happens that the solutions to x squared minus 2x minus 3 equals 0 are -1 and 3. -1 and 3. F of x equals x squared minus 2x minus 3 is the function. X squared minus 2x minus 3 equals 0 gives me my x-intercepts. And the solutions to this equation are the x-coordinates of the x-intercepts. We have another problem like this over here. Here we have what's called a cupped down parabola. All right, this is the graph of f of x equals 15 plus 2x minus x squared, which is really annoying because it should really be written as negative x squared plus 2x plus 15. Nonetheless, they have the same graph. If I want to find the x-intercepts, I set 15 plus 2x minus x squared, or negative x squared plus 2x plus 15, equal to 0. And the solutions to this equation are the points on the x-axis that are the x-intercepts. There's a very close relationship between x-intercepts of a quadratic equation and the solutions to this quadratic equation. Or I should say, how can I say this? The solutions to a quadratic equation that equals 0 are the x-intercepts when they exist. You'll learn a lot more about that in college algebra. Now, we've got some word problems. An envelope. This is my rendering of an envelope. An envelope is 6 centimeters longer than the width. So the width is W and the length is W plus 6. When we solve all this, we find out that W equals 6. We're told that the area of the envelope is 72 square centimeters. Well, area of a rectangle is length times width. So 72 equals W plus 6 times W. Distribute the W into the parentheses so that we get W squared plus 6W equals 72. Use the zero principle and bring 72 over. That is, since it's a positive 72, subtract 72 from both sides of the equation. Now you've got 0 equals W squared plus 6W minus 72. Since there's an invisible 1 in front of W squared, factor the constant at the end, negative 72. I wrote down all the factors. 1 times negative 72, 2 times negative 36, and so on and so forth, and discovered that, here are the numbers I want. Negative 6 times positive 12 is negative 72. Negative 6 plus positive 12 is positive 6, which is the coefficient of the linear term. So, that tells me how I can factor w squared plus 6w minus 72, and then I set each factor equal to 0 and solve for the variable. Here I get w equals 6. Here I get w equals negative 12. See, let's make that negative darker. Well, we're talking about the width of an envelope. There's no such thing as a negative width. There is actually when you get to physics, but not in math. Okay? So we mark that out and we go with the width equals 6. That means that the length, which is w plus 6, is going to be 6 plus 6, which is 12. And so those are our answers right here. 6 centimeters for the width, 12 centimeters for the length. Now, here's a kind of problem you see a lot of in intermediate algebra and in college algebra. You've got a picture frame and you've got a picture. The picture frame is X centimeters wide. The frame is 20 centimeters by 18 centimeters. Find the length and the width of the picture. Not the picture frame, we already know that. But, well, all right, not of the picture. We're being asked to find the width here of the picture frame. That's what we're being asked to find. So I have to find a way to use X. All right, they also tell us, the people who wrote the problem, that 168 squared centimeters is the area of this lovely picture that I drew of a flower in the mountains with the sun shining. Isn't that lovely? Yes. The area of this picture is 168 squared centimeters. It's a rectangle, the picture is. And the area of a rectangle is the length of the picture times the width of the picture. That is, the area of the picture is the length of the picture times the width of the picture. Notice that the length of the picture is the original 20 centimeters minus this X minus this X, so that the length of the picture is 20 minus 2X centimeters. The width of the picture is the original 18 minus this X and minus this X. So 18 minus 2X is the width of the picture. This is the length. This is the width. The area of the picture equals the length times the width. Multiply them together. You'll have 168 equals 20 minus 2x times 18 minus 2x. Take the 20 right here and multiply it by the second set of parentheses. And then take the minus 2x and multiply it by the second set of parentheses. work all this out, combine your like terms, and then subtract 168 from both sides of the equation. That's the zero principle. So we have 0 equals 4x squared minus 76x plus 192. I notice that there's a 4 in each of these terms. Negative 76 is negative 19 times 4, and positive 192 is 48 times 4. I pull 4 out as my GCF, and the leftovers are x squared minus 19x plus 48. Then, because this is an equation, only because it's an equation, I can divide out the 4. I divide both sides by 4. That cancels out the 4, and I'm left with just the leftovers, x squared minus 19x plus 48. Now 48 equals negative 3 times negative 16, and negative 3 times plus negative 16 is negative 19, which is the coefficient of the linear term. So that tells me how to factor x squared minus 19x plus 48. Then I set each factor equal to 0 and solve for the variable. Now I've got two possible choices for the width of the picture frame. The width of the picture frame can be 3 centimeters, or it can be 16 centimeters. Except if x is 16, then I would have 16 plus 16, that would be 32, which is longer than 20. And 16 plus 16 would be 32, which would be longer than 18. That makes no sense. I cannot use 16. So 3 is my best answer, 3 centimeters. The width of the picture frame is 3 centimeters. And that's what I've been asked to find. Find the width of the frame around the picture. Remember, you can always back this up and go forward again. Now, here's a problem just like this first problem. You've got a rectangle, you're given the area. Area is length times width. Here you're told that the top of a workbench, in the top of a workbench, the length of the top of the workbench is 5 meters greater than the width. That is one heck of a workbench. So if this is the width, then the length is going to be 5 meters greater. And the area is going to be 104 square meters. I do this problem just like I did that first word problem. So go through my steps here and check this out. Now we've got a Pythagorean theorem problem. Remember that when you have a right triangle, well, I stand no chance of drawing a right triangle. I stand a good chance of drawing a wavy triangle. So I actually have, let me make this bigger. I actually have drawn a triangle here with the straight line tool. Yeah, with the straight line tool, Just making sure this is recording. I'm certainly hoping this is recording. I feel worried about it, but let's continue. Here's the wire that goes from the top of the antenna to the ground. Here's the distance on the ground from the end of the wire to the bottom of the antenna. And here's the height of the antenna, of the top of the antenna, above the ground. Now, when you have a right triangle, which should look something like this, where this is your 90-degree angle, this side is usually called A, this side is usually called B, and this side is usually called C, and the Pythagorean theorem is a squared plus b squared equals c squared. You only find the length of the sides with the Pythagorean theorem. You're never finding the area, only the length of the sides. Well, in this problem, A is called the height, B is called the distance, and C is the wire. So we're going to say that, let me move over here, h squared plus d squared equals w squared. Now this is some more of the information we're given. A wire is stretched from the ground to the top of an antenna tower. The wire is 25 feet long. The height of the tower is 5 feet greater than the distance from the tower's base to the end of the wire. So these are our dimensions. The height is d plus 5. The distance from the base of the antenna out to where the wire ends on the ground is d, and the wire is 25. So, since h is d plus 5, I've got parentheses d plus 5 squared plus d squared equals 25 squared. 25 squared is 625. Over here, I multiply d plus 5 times d plus 5. And this plus d squared is still there at the end. So that I end up with d squared plus 5d plus 5d plus 25 plus another d squared equals 625, which gives me 2d squared plus 10d plus 25 equals 625. Now we're going to use the zero principle. Zero principle. Let's just say pren. I think that's a good idea. I'm going to subtract 625 from both sides of the equation, and that will give me 2d squared plus 10d minus 600 equals 0. And each of these terms contains a 2. So I pull out the 2. 2 is my GCF. 2 times the leftovers d squared plus 5d minus 300 equals 0. I divide both sides by 2. Again, I can only do that when I have an equation. 0 divided by 2 is 0. 2 divided by 2 is 1. So I have d squared plus 5d minus 300 equals 0. Negative 300 equals negative 15 times positive 20. And negative 15 plus positive 20 equals 5. So that tells me how to factor. I set each factor equal to 0, and I solve for the variable d. D is distance. It can't be negative. That's a negative 20. That makes no sense. So we're going to let d equal 15. That means this distance is 15. D plus 5, if d is 15, is going to be 15 plus 5, which is 20. Therefore, the distance from the wire to the tower is 15 feet, and the height of the tower above the ground is 20 feet. And we have found our dimensions. With some practice, you'll be able to buzz right through these, but it's really important that you do these problems and try to do them a couple of times. And we'll work on these. Talk to you later. Bye-bye.